Okay, so we are continuing with lines. We've got one method left for finding out where they intersect. We have done graphing, which had its limitations just because it's hard to graph, then get a clear intersection point. We had substitution, and now we have one called elimination. Now, the idea behind elimination is we're going to treat this as if this was one giant addition problem. Okay, like it was one giant arithmetic problem from back in elementary school, where what we want to do is we want to add so that it would disappear. We're going to get one of the variables to just drop out. Now the trick is we need something to be the opposite of each other. And so what I mean is if I were to multiply this top equation by 2, that wouldn't be breaking anything because I've changed the entire equation all the way through by multiplying by 2. So it's still the same equation. Well, that would then create an opposite here in the middle where you'd have 2y and negative 2y. Those are opposites, and if I turn this into a big addition problem, those opposites will disappear. Let's see if they're doing the same one. Yeah. So they multiplied that top one by a 2, okay? So here's what we'd have. I've multiplied through by 2. Now look, these are opposites. So let's turn this into a giant addition problem. These are going to now add up and disappear. And these add up. I've got 5 x's now. X must be 4. Now, we've gone this far. All we need to do is what we did last time. Put that 4 into either equation you want, and you get the value for y. Now, the use between the two, sometimes something is set up super easily for substitution, and sometimes it's set up more easily for this elimination. That's why you would choose between the two, but they'll both get you to the same place. So try this one if you want, but I'll show you here if you just want to see it. I see that all I have to do is multiply a 3 through there, and I could get these y's to be opposites. So I'm multiplying that entire top row by a 3. Okay, do you see that I've now created something that with my giant addition problem, these will drop out? I'm going to have 11x equals 22. So x must be 2. Now put that into either equation. It doesn't matter. I'll put it into the bottom one. So y is going to turn out to be negative 1. Now, put that into either, oh, I've already done that. Forgot where I was. So I've got everything now. I've got 2, negative 1, and that's the solution to the system. That's where they intersect. All right, let's try another one here. Yeah, this is what I thought. If you look at here, there's no easy substitution. Like one multiplication is not going to do it. Sometimes we have to multiply the top and the bottom. And so I have opposite signs here. I've got a negative 3 and a positive 2. So what will always work is if I multiply the bottom by that 3 and the top by the 2, I'll create the opposites. So follow me here. They're going to do the 2 times the top, and they got that from here. They're going to do the 3 times the bottom, which they got it from there. Now, that has created those opposites, and you'll add up. You get 29x equals 0. X must be 0. Sub it in. You get this. Okay, let me show you. So we want to create the opposites. It can be in anywhere we want, but because we have these opposite signs, let's do a 3, which I got from here, and a 4 on the bottom. Now we've got 9x minus 12y equals negative 27. 20x plus 12y, what would that be, 54? Okay, now we create our giant addition problem. The y's are gone, which is why we chose it. We had those opposite signs. I was not expecting such strange numbers, but it appears to be the case. Yep, I don't know why, but that appears to be it. Why such oddity? Let me double check myself here. Oh no, it's this one, I think. This is what I'm worried about. Did I do this right? I did not. Should have been 56. Okay, which would get us the 29. Okay, so 29 divided 29, we should got x is 1. Okay, now we can put that into either equation. I'm going to put it in the top one. So I've got 3 minus 4y equals negative 9. So dividing both sides by a negative 4, I get y as 3. So my solution to my system is 1, 3. Again, it doesn't have to be the x that you, or the y that you get rid of first. It'll work either way. Okay, now what we're going to do here, we're going to clear out the fractions first. I do not want to try to solve this by just trying opposites with fractions. That would be a nightmare. But we've seen the trick in the past where I can multiply by the LCD all the way through here, and that will clear out the fractions. So I'm going to multiply that first one just by 2. This isn't going to solve it. I just want to get rid of the fractions. And the bottom one by a 6, and that will clear things out. So I'm doing a 2 all the way through the top, a 6 all the way through the bottom. Now, I have two equations that are free of variables. Now, this still isn't good enough. Like, I am not ready. Like, I'm ready now to just begin what we did before, but nothing eliminates. But if you see, if I can run through a negative 4 now, I can do this again. I'm going to multiply everything by negative 4, and I'll now set up this top one to have that opposite in the middle. So I'm running through my negative 4, I create this. It's now a giant addition problem where those are opposites. I get x is 3. All right, so let's put 3 into either one of the equations. I solve this. You're going to get y is 6. So there's my solution. All right, let's try one of these on our own. Let me see what we got going here. Hold on. Give me just a moment to see where we're at in the big picture here. Okay. All right, so I am going to find the LCD. That'd be a 6 for those guys. And for here, it would be a 4. Now, when I multiply through here, 6 times 3, do you see this will cancel down to a 2? And so I'm going to have 2x. The 6 goes to the negative 1/2. That'll be a 3. And then the 6 has to go to this side too. Some students will forget that. It's got to go all the way over. That'd be a 1. Now, the 4 times 3/4, those would cancel. And I'd just be 3x. The 4 would go to this middle term and be minus 4y. And the 4 will go to this last term, and that would be a 10. Don't forget the last term. So a 4 is getting multiplied by each of these groups, this group, and that group. All right, now this didn't solve anything. It just got us set up here in order to play the same game we've been playing. Now there's multiple ways you could do this, but what I'm going to do is I'm going to choose negative 3 on this one and 2 on this one. I'm going to set up so the x's drop out here. Now negative 3 going through here, I got negative 6x plus 9y equals negative 18. That's 6x minus 8y equals 20. Okay, a big addition problem here, and I'm left with 1y equals 2, so that's what y is. Y is 2. Now let's go into any equation we want, and actually the book didn't do this, but you can use these new revised equations. It doesn't have to be the ones with the fractions. So I'm going to use this right there, the one that we cleared out the denominators. I'm going to use that because it will work just fine. So I've got 2x minus 6 equals 6. 2x is 12. X is 6. So my solution is 6, 2. All right, we have another one here where we'd want to clear out this bottom first by multiplying all the way through. Well, a couple things here. The first thing I would do is multiply through by the 4 to get rid of the fraction. So let's see if that's what they do. Yeah, well, they rearranged it first. That was what I was going to say you could do second. We want to get this so that we have these set up in front of each other. So let's move the 3/4 x over to the other side. Now we'll multiply through by a 4. And now look what's happened. We actually have the same line. So if we can multiply through by a negative 1, and we'd see we'd have all opposites. What we'd be left with is 0 equals 0. Well, I mentioned this in the last video. That is telling the truth. So this is infinite solutions. What's happening is those are the exact same line. They're laying on top of each other and they're touching everywhere. Now, I have a feeling this is going to be the one where we have no solution, but let's try it. I'm going to first swing this over to the other side. So I've got 5/3 x plus y equals -5. Okay, now let's clear this bottom one of that problem with the fraction. So we're going to make this, I'm going to just rewrite the top one. Now the 3 is going to cancel with that 3. I'm left with 5x. 3 goes to the y, I get 3y. 3 goes to the -15, makes -15. Okay. Yeah, I made sure I was right because something strange is going to happen. If we now turn these into a big addition problem, I already have it set up that these are opposites in the middle. I didn't know that would happen. No, something's wrong here. I don't think that's what they intended to happen. Yeah, when I swing this over, I'm sorry. When I swing this 5/3 over, it should have been -5/3 x. And then when I multiply that, it's going to be -5x. So I missed that sign. He's coming over becoming -5/3 multiplied by 3, it's -5x. Now here's the point. Now if I do my big addition, everything on the left is going to drop out and everything on the right is going to drop out, and actually it's 0 equals 0 again. So this is infinite solutions again. These are the same line. Okay, now they didn't do one that didn't tell the truth. So if we had dropped it out, remember, and it had been 4 equals 7 or something, that is not true, and you would have said no solution. Those would have been parallel lines. Okay, but so these, the x's and y's dropped out and it told the truth, infinite solutions. Now our last slide here, it's going to talk, we have our 3 methods for choosing. So, but the easy answer is this. If it is set up, this is called standard form here on A. If it's in standard form, it's probably easiest to just go ahead and do the elimination one that we did today. But this one, look at B, I've already got something set up where x is solved for. So this would be substitution, our last method. I already know what x is, so why don't we just go ahead and sub it? Or you could have had something like, suppose you had something in standard form, but it would have been very easy to solve for y. Well, we'd go substitution there too. So again, one more time, this is set up in standard form like they're all set up to do our big addition problem. Nothing is easy to solve for. I'd do elimination. Here, I've already got something subbed, so I'm doing like ready to substitute. I would just go ahead and do substitution. And then lastly, maybe you've got them in standard form, but this would have been easy to solve for. I could have easily found that this would be y equals. So in that case then, I would do substitution. Okay, I hope that gets you going. I hope that makes sense.